In this tutorial, we will look into how to use filters in our Jakarta Java Enterprise Edition 8 web application. We will look at how we can use filters in Jakarta Enterprise Edition version 8 web development. We will try to understand the fundamental purpose of filters in web applications. We will learn how to create and configure filters to intercept and process requests and responses. We will discover the importance of ordering filters correctly to ensure desired behavior. And we will do that through a code example. And we will also look at real-world scenarios where filters simplify tasks, such as streamlining authentication. In the first headline, we will review the importance of filters in web development, emphasizing their role in enhancing functionality and security, and highlighting key topics including the Jakarta Filter API, Oracle's insights, filter declaration methods, and common use cases. When it comes to creation and configuring our filters, we will attempt to understand the filter chains. We will look at mapping URL patterns and servlet names. We'll look at mapping to different request dispatcher types. And we will use the web XML deployment descriptor. We will also look at using annotations in code. And finally, we'll look at programmatic configuration of filters. Next, we will learn how to apply order to filters when we use multiple filters on a resource, as we see here in the side diagram on the servlet. We will look at URL pattern mapping versus servlet naming, and we will explore the filter order with a code example. We will look at two practical examples of how to implement filters in the code. We'll look at a compression example, and we will look at a logging filter. Finally, we update our charity registration example to use filters to authenticate the user with our login JSP. And now we go over to course documentation and select the filter section. And here we see an overview of what we just covered in the slide. We're going to look at the purpose of filters, at how to create and configure filters, how to order our filters, and then we have code examples. First, the filter order example. Next up, we have more filter examples. And finally, we're gonna filter for login authentication. So let's start by looking at understanding the role of filters. So filters play a vital role in web development by intercepting and modifying requests and responses. They offer the capability to reject, redirect, or forward incoming requests, providing a flexible way to enhance the functionality and security of web applications. Before we look into detail, we need to understand the foundations, and for that we can reference the actual official Java doc and do a deep dive in here. This is the filter interface with the implementation classes. And next up, There is also the Oracle filter documentation, which explains the essentials of filters. This is a good document to review in your own time. Essentials, programming filters. They also have a logging example. We will look at our own logging example. They have a character encoding example and customized request and responses. And they also have a compression example. And we also have our own compression example that we'll look at. As mentioned, this is for your own perusal. Back to the purpose of filters, the declarations of filters. We can use a web XML deployment scripter, or we can use Java annotations in our code. Then we're going to look at the relevant common use cases. As mentioned, we are going to be looking at our own logging filter example. We are also going to be looking at our own authentication filter example. And finally, we will be looking at our own compression and encryption example. And for extra credit, we have error handling filters, which you can set up in a cloud. So in conclusion, filters are versatile components in web development, serving essential roles in logging, authentication, performance optimization, security, and error management. Understanding their use cases and implementation can significantly enhance the functionality and the reliability of our web application. Now let's go back to our filter overview and we go to creating, declaring, and mapping filters. So in order to create a filter, we need to implement the filter interface, and we have two known implementation classes. We have the init, the destroy, and the do filter. And in most cases, we will use the HTTP filter implementation. We're going to look at understanding the filter chain through our own filter chain example, which we'll implement in our parity registration web app. Filters operate in a sequence known as a filter chain. This chain determines how each filter processes requests, and we're going to look at the filter chain example. Filter chain passes requests from filter to filter until all filters have processed the request, ultimately reaching the servlet. And if this chain is interrupted, the request may not reach its destination. I'm going to look at mapping filters. First, mapping to URL patterns and servlet names. So this is basically what we already do with servlets to ensure they intercept the relevant requests. And we can do multiples of these. Then filters can also be mapped to different request dispatcher type depending on the nature of these types. We can filter error requests. We can filter forward requests. We can filter include requests and normal requests. There is also an async request handler that we can use for asynchronous operations. So first, filters can be configured using the web.xml. Here is the example which we will use to look at filter chain. Filter A defined, we've got it mapped to full reach of the application. Then we have filter B defined. We have mapped it to two specific paths, which includes servlet names. Then we have filter C defined, and we have mapped it to one of the servlet names that is also defined for filter B. Now you can also use the programmatic web filter notation to configure your filter. Here is an example of a web filter. The filter name, the URL patterns, servlet names, and the specific dispatcher types for the filter. And also note that it limits your ability for ordering filters on a filter chain. Here is the programmatic configuration of filters. You can dynamically register filter using the servlet context and servlet context listener. So here is a test filter defined. Here is URL parameters defined with the type. And here is the servlet names defined as well. Here you have more fine-grained control of the filter configuration. Understanding how to create, declare, and map filters is crucial for optimizing and securing web applications. Filters provide a flexible mechanism to intercept and process requests, making them a valuable tool for modern web development. Now let's go back to our headline overview, and we go to step 3, which is ordering your filters properly. Basically, filters are applied to incoming requests, and the order is crucial. For instance, when we do authentication and authorization, we have to authenticate, meaning we have to know who the user is before we can authorize the user to the assets in our web app. Here we have an overview of setting the filter order. Now currently in the Jakarta 8 framework, annotation is not directly supported, and we have two methods of applying the order of our filters. The first is in our web.xml configuration, or we can do programmatic configuration. And here we start with a preview of our actual filter order example. So we will look at a web XML configuration, and this is the example which we will use. We will define 3 filters. We will define 3 servlets, a filter A, a filter B, and a filter C, and we will configure the order for these 3 filters and 3 servlets. We can see in the figure above, different requests to different servlets are mapped to different filters. They share the same high-level order. URL mappings take precedence over servlet name mapping. So here is how it's defined in the web.xml. Filter A is defined, and we see that filter A applies to everything in terms of our URL pattern. So we see every single request coming to our web server will be intercepted by filter A. Then we have filter B defined, and we see we map servlet 2 and servlet 3 to filter B. So if we go up, here is servlet 2 and servlet 3 will also go through filter B. And finally, filter C is defined, and filter C will only intercept servlet 2. So this is filter C, and it will only intercept servlet 2. So basically what we see is servlet 2 goes through all 3 filters. That is the case. It goes through 1, filter A, 2, filter B, and 3, filter C. This sequence is determined by the fact that URL pattern mappings take precedence over servlet name mappings. In conclusion, properly ordering your filters is crucial for defining the logic and sequence of actions on incoming requests. Understanding this distinction between URL pattern and servlet name mapping is vital to ensure that filters execute in the desired order. While annotations may not directly support filter ordering, using the deployment descriptor in web XML and programmatic configuration methods provide the necessary control over filter order in our web application. Now we are going to go back to our filter lesson, and we are going to look at exploring the filter order with a code example. And in here we have the links to our GitHub code example. This is servlet 1, and basically all these servlets does is tell us when it's entered and when it's leaving. So we have servlet 1, 2, and 3, and then we have our filters, filter A, and we specify when it enters the filters and when it leaves the filter. And then we have our web.xml, and here we start with our filter configuration. We define filter A. Filter A will be mapped to any URL string of our app, and we define filter B. Filter B will only be mapped to servlet 2 and servlet 3, and we define filter C, and filter C will only be mapped to servlet 2. Now we are going over into Eclipse, and first we look at our web XML. We see our filter definition of filter A. We see the filter mapping. This URL means every path of the web app. Filter B defined, and it is mapped to URL pattern servlet 2 and servlet 3. Then we see filter C, and filter C is mapped to servlet 2. So basically it's the same as in the documentation diagram. We look at filter A, and in each of these filters, basically all we do is we output to the log the entering and leaving of the filter, and we call the do filter on the chain with the request and response. For the servlets, we essentially have the same thing. Basically, we output to the log that it's entering servlet and that it's leaving the servlets. And in cases like these, we output to the JSP or the web output the text of the servlet. Now, when we look at index.jsp, we have activated the redirect to the activity session servlet. And if we look at the activity session servlet, here its URL mapping is defined in the code with an annotation. We specify the entering and leaving to the log. It does a record of session activity, where it essentially does logic to get these session values and IP addresses and add it to a page visit list. And then we have the view session activity, and this forwards to the view session activity JSP. And the view session activity is mostly this Java code running in the servlet page and going through each of those page visits in the list and outputting the detail such as the IP address and the length. Let's get ready to run our application. We remove it from our Tomcat server at localhost A. We clean Tomcat in our project. We select charity registration, run as run on server, Tomcat localhost A, where only the charity registration is there, and finish. And here it is hitting the activity session, and it shows us all the details of that session. And if we look at our log, There's entering filter A, leaving filter A. So that must be hitting the redirect and then entering filter A, and then it's entering our activity servlet and leaving our activity servlet, and then it is leaving filter A. When we go at look at our web XML, we expect that servlet 2 will hit all of our filters because filter A will intercept everything. Servlet 2 is defined in filter B and filter C. So let's copy and paste the URL and we plug it in there. And here we see the servlet 2 output. And if we go look at our log, after it left filter A with the first activity servlet, now we got filter A, filter B, filter C, and then it enters servlet 2, it leaves servlet 2, and we see it leaves filter C, B, and A. So that kind of maps the diagram in our documentation. And if we look at the mapping for servlet 3, we expect that it will be going through filter A because it catches everything. We expect that it would go through servlet B because it's mapped to the pattern, but we do not expect it to go through filter C because it's not mapped. Let's go to the web browser and plug that in. Servlet 3. We see servlet 3 displayed. And now if we work backwards from the entering and leaving of servlet 3, we see we have filter A and B entered and filter B and A left. So we see the last filter to enter will be the first filter to leave. And that covers our filter order example. So now we will go back to our documentation. We have just explored the filter order with the code example. Now we will be looking at practical uses of filters, and we will look at a charity compression filter and a charity logging filter. Here is the compression filter, and we see we make use of the zip utility class from Java, and the filter accepts the input request and then zips it up and return it to the output. Then we have the logging filter, and the logging filter logs all the details of the filter, and it does this by a print formatting. It passes in a bunch of relevant information. And in this example case, we actually use a configuration class wherein we register our filters. So here is the compression filter registered, and here is the request log filter registered. Here is the response wrapping explanation, encapsulating the response object to manage the flow of data efficiently. This is what the zip compression does, and it outputs it back to the servlet output stream. So now we are ready to go back to Eclipse and look at the practical implementation. Back in Eclipse and looking at our web XML, we disable our filter ordering configuration, and now we use our new configurator class. Here we add the request log filter, and it is mapped to everything coming in. And here we add the compression filter, and it is mapped to everything coming in. We look at the request log filter. We set up the chain, do some error handling, and finally we log the details. And here is our logging, where we do a printf with all the data such as the remote address, the time elapsed, the method, the request URI, protocol, the status, and the length and the start time. Then we look at our compression filter. We have the do filter, where we check if encoding is requested, and we set the response header. Then we use a wrapper to wrap our response, set up the chain, finish the wrapper, or if the encoding is not requested, we just do the filter. Here is our response wrapper, where we wrap the servlet output stream in a zip servlet output stream. And we also do it for the print writer. And then we have some fancy buffer writing and header handling methods. And we have to finish the writer, close it. And here is the actual gzip servlet output stream, where we implement our servlet output stream. Now looking at our index.jsp, we will keep using the activity session. And now let's run it. Run as run on server, Tomcat server localhost A, charity registration. Here is our session activity JSP. And if we go back to our console, we see entering the request log filter, entering the compression filter, encoding requested. In encoding, wrap the servlet response. Then we have leaving the compression filter. Then we have a log statement. And then we leave the request log filter. And then we do the redirect. So we do the cycle again with the request log filter first, then compression filter, then wrapping the servlet response, entering the activity servlet. This is the output from the activity servlet. Then we leave the activity servlet. We leave the compression filter. Here is a log statement from the request log filter. And finally, we leave the request log filter. So that covers our logging filter and our compression filter. And now we are ready to go back to our servlet documentation. This is the practical implementation documentation of the compression filter and the logging filter. And if we go back to our filter overview, we are now ready to look at authentication with a filter. So now we will add user authentication to our charity registration. We will centralize our login validation in a filter, making our code more maintainable. In our charity registration servlet, we do not have any login validation. And in our session list servlet, we've commented out the previous login validation. And we've added an authentication filter, which essentially checks if the user is logged in via the session and the attribute and redirects to the login page. And we've updated our configurator class where we register our filter. We commented out our previous logging and compression filter now. And we just define the authentication filter and the mapped URLs. So now we are ready to run and test our application in Eclipse. And here we are in Eclipse, looking at our session list servlet. We no longer do the redirect to the login within the do get. We have set up our registration filter to actually do that on these two mappings. And here we check if session is null or if the username is null, and then we redirect to the login page. In the charity registration servlet, we do not have any redirects to the login page. Before we run our charity registration, let's look at our index.jsp, and now we have enabled the redirect to the charity registration servlet. So let's run it. Run on server, select localhost A, finish. And here we see our login page with username and password. And if we go back to our login servlet, we see we still use the in-memory database with our ultra-secure username and passwords in plain view for the whole world to see. So let's choose one of them to log in. And we've logged in via the login servlet. We can list the active sessions. We can list the active charities. And we'll register a charity. We've entered and submitted a charity. And now we can list it. And finally, we can log out. And we are back to the login page. We've come to the end to our filter overview. We have explored the purpose of filters. We have learned how to implement the filter interface and how to create and map our filters to resources. We learned about the filter chain and filter order. And we learn about request handling through examples such as our compression and logging filter. And finally, we've done an proto authentication filter. And that concludes this tutorial. I will see you in the next one.